Hello everyone, this is Rashad from the College of Engineering. Today I'm doing a video lesson about Markov chains in mathematics. So, firstly, we'll explore the fascinating world of Markov chain. It is a powerful mathematical concept used to model system behavior and make predictions. So, let's start. So, today we are learning the definitions of Markov chain, the basic probability and transition matrix, and properties of Markov chain. So, we'll explore the key properties of Markov chains, including Markov or Markov properties and stationary distribution. So, what is Markov chains? A Markov chain describes a discrete line stochastic process over a set of states. So, when we take S, so S is equals to S1, S2 till Sn. According to transition probability matrix, P is equals to P of ij. So Pij probability of moving to state j when at state I. So summation of j P of ij is equals to 1 stochastic matrix. So this is the stochastic matrix. So what is memorylessness properties? The next state of the chain depends only on the current state and not on the past of the process. So it is called as first order MC. So higher order MCs are also possible. So Markov chains, named after the Andrew Markov, who was a Greek mathematician who found the Markov chain. It is a stochastic model that depicts the sequence of possible events where predictions or probabilities for the next state are based solely on its previous event state, not the states before. In simple words, the probability that n is one step will be x depends only on the nth steps, not the complete sequence of steps that came before n. This property is known as Markov property or memorylessness. Let us explore Markov chain with a perfect diagram. So this is E and this is A. So as we know, n plus one step will be x depends only on the nth step, not complete sequence of the steps that came before n. So properties of Markov chain. A Markov chain is said to be irreducible if we can go from one state to another in a single or more than steps. It is the irreducible. It is irreducible. A state in Markov chain is said to be periodic. If returning to it requires multiple of some integer larger than 1, the greatest common divisor of all possible return path lengths will be the period of that state. So a state in Markov chain is said to be transient if there is a non-zero probability that the chain will never return to the same state, otherwise it is recurrent. The state in the Markov chain is called absorbing if there is no possible way to leave that state. Absorbing states do not have any outgoing transitions from it. So the applications of Markov chains. So the Markov chains are widely used in weather forecastings and customer behavior patterns, then predicting the stock market. So firstly, when we see the Markov chains in real life systems such as weather patterns, the weather patterns are predicted from the Markov chains and customer behavior. We grab the customer or customer appearance or customer visiting to the website by calculating using the Markov chain. We can grab as many as customers. It is widely used in e-commerce businesses. So it is also used to predict the stock market and the trends and downs of the stock markets. So the advanced topics in Markov chains are reducible and irreducibles, then limited behavior of Markov chains and recurrence and transients, Markov chains, Monte Carlo methods. We'll learn this Markov chains, Monte Carlo methods in the next slide. So the Markov chains make the study of many real-world processes, as we know before we looked into the weather forecasting and the customer behavior, probability, and the analysis of stock market. We have looked into it. So we We also use the results such as stationary distribution and many more. So MC, what it is called as MC is Markov chain Monte Carlo. And as we saw in the previous slide of the advanced topic, we have seen the Markov chain Monte Carlo, which gives a solution. So this Markov chain Monte Carlo gives a solution to the problems that come from the normalization factor is based on Markov chain. So the Markov chains are used in information theory, search engines, speech recognition, etc. So this chain has used possibilities in future and important field of data science who are looking in the data science field so can go through the Markov chain and the Markov chain probabilities. So as we have seen, it is also used in information theory. And informations are being uh, stored in data where this data can be accessed or manipulated uh, through various techniques. And one of the technique is using the Markov chain. Even in search engines and speech recognition, the search engines, as we know, as we are familiar with the Google search engines, these search engines are uh, holds wholly dependent on the Markov chain. They predict uh, the assumption of the user when we type something as Markov chain. It predicts the next words of the sentence as Markov chain in mathematics, Markov chain in computer science. So the probabilities are being shown to us so that the user get convenient to it. So speech recognition, it is also used in speech recognition. The speech recognition follows a pattern or a sequence of the probability where it repeats the words familiar to it, and this where the Markov chain is widely used. So Markov chain model for the DNA. Even in the field of biology or in the field of biotechnology, we use Markov chain. In every field of science, we use Markov chain. So now we will see a Markov chain model for DNA. So this is the transition, and this is the state, and this is the begin. So we begin from here. It can be A, it can be C. So from A to G, C to T, then T to G, then G to A. It may be irreversible process. Even it may jump from A to T and C to G. Now let us see the transition probabilities. So PR, x of I is equals to A, or x of I minus 1 is equals to G. So which is equals to 0.16. It is zero point 0.6, and you can see this 0.68 G. And PR, x of I is equals to C, or x I minus 1 is equals to G is equals to 0.34. So this is the 0.34, and PR, which is probability, x of I is equals to G, or x of I minus 1 is equals to G. So from this is the G probability, which is 0.38, and PR x of I is equals to T, or x of I minus 1 is equals to G. So T and G, which is the probability is 0.12, which is here. So next, assumption for Markov chain. What are the assumption of Markov chain? The statistical system contains a finite number of states. States are mutually exclusive or collectively exhaustive. The transition probability from one state to another state is constant over time. So Markov processes are fairly common in real life problems, and Markov chains can be easily implemented because the memorylessness property. So due to its memoryless property, we can use frequently or implement anywhere. Using Markov chains can simplify the problem without affecting its accuracy. So these are the topics, and we covered every a bit of aspects in Markov chain. So this was my topic, and thank you. Have a nice day.